Okay, hi everyone, welcome back to this live stream from Windows Server 2003. So I just want to share my screen. Okay, the logging tab. The logging tab contains 4 radio buttons that you use to control what information IP routing components of RRAS log. These radio buttons include the following. The log errors only radio button instructs the server to log IP routing related errors and nothing else. This gives you adequate indication of problems after they happen, but it doesn't point out potential problems noted by warning messages. The log error and warnings radio button is the default choice. It instructs RRAS to log error and warning messages to the event log without adding any informational messages. If you get in the habit of carefully reviewing your event logs, these warning messages may give you welcome forewarning of incipient problems. The maximum amount of information radio button causes the IP routing stack to log messages about almost everything it does. This gives you a lot of useful fodder when you're troubleshooting, but it can flood your logs with minutiae if you're not careful. Don't turn it on unless you're trying to isolate and fix a problem. The disable event logging radio button turns off all IP routing event logging. So you can see here figure 918, the logging tab of the general properties dialog box. The preference levels tab. The preference levels tab gives you a way to change the router's behavior by telling it what class of routers to prefer. In the earlier discussion of routing, you read that the router selects routes based on cost metric information. There's another factor that comes into play, the preference level of the routing source. The default configuration for RRAS causes it to prefer local and static routes over dynamically discovered routes. So you can see here, figure 919, the preference levels tab. For example, say there are 2 routing table entries that let me start again. For example, say there are 2 routing table entries indicating routes to 216.80.*, one that you've entered as a static route and one that your router has discovered via a RIP peer. In this example, the router will always try to use the static route first. If it can't, it'll try to use the RIP generated route. You can change the router's class preference by selecting the class you want to change and by using the move up and move down buttons. Managing routing protocols. Routing protocols typically don't take a lot of management. Once you install RIP or OSPF, the protocol engine takes care of exchanging routes with remote routers, unlike what you may be accustomed to with dedicated routers using a router OS. Like Cisco's iOS, there's no way to directly edit the contents of the routing table generated by dynamic routing protocols. That means your management of these protocols is pretty much limited to installing them, configuring them to meet your needs, and watching them as they run. In the following sections, you will examine the details of installing routing protocols and setting routing protocol properties, installing RIP and OSPF. You add routing protocols from the general sub-node beneath the IP routing node in RRAS. This is quite different from the way you manage network protocols in Windows NT, but it makes sense. There's no reason to install RIP or OSPF unless you're using RRAS, so it's logical that you would install it from there. Exercise 9.3 explains how to install the RIP and OSPF protocols. You'll need them installed for later exercises in this chapter. So 1. Open the RRAS MMC console by selecting Start Administrative Tools, Routing and Remote Access. 2. Select the server you want to configure in the left pane of the MMC. Expand it until you see the general node beneath IP routing. 3. Right-click the general node and select New Routing Protocol. The New Routing Protocol dialog box appears. 4. Select the routing protocol you want to install. In this case, choose RIP version 2 for Internet Protocol and click the OK button. 5. The RRAS console refreshes its display, revealing a new node labeled RIP under the routing node. 6. Right-click the general node and select New Routing Protocol. This time, when the New Routing Protocol dialog box appears, select Open Shortest Path First OSPF and click the OK button. Setting RIP properties. The RIP protocol is pretty much self-tuning. Once you configure an RRAS router to use the RIP protocol, it will look for peers and exchange routing information without a whole lot of effort on your part. There is a small group of settings you can change through the RIP properties dialog box, which you open by selecting RIP node under RIP routing in the RRAS console and then choosing Action Properties. We look at the various tabs of the RIP properties dialog box in the following sections. The General tab. The General tab has the same login controls you saw on the General tab of the IP routing properties dialog box. The maximum delay control governs how long the router will wait to send an update notification to its peers. The Security tab. The Security tab lets you control what router announcements your router will accept. By default, the RRAS RIP implementation will ingest routes supplied by any other router. You can restrict this behavior by supplying either a list of routers to trust or a list of routers whose routes you want to reject. So you can see here figure 9.20, the General tab of the RIP properties dialog box. Figure 9.21, the Security tab of the RIP properties dialog box. Setting OSPF properties. You can also set some OSPF properties. You can also set some OSPF specific properties by selecting the OSPF node under the IP routing item in the RRAS console and opening the OSPF properties dialog box, the General tab. The General tab of the OSPF properties dialog box contains the login controls that you've already seen twice in this chapter, plus 2 additional controls that you'll probably have occasion to use. Figure 9.22, the General tab of the OSPF properties dialog box, and it has the IP address there, 192.168.0.144. These controls include the following. The router identification field allows you to enter an IP address that your router uses to identify itself, although it's not a good idea to assign a bogus IP address as your router's identifier. You may want to choose the public IP address even for internal interfaces. The Enable Autonomous System Boundary Router checkbox controls whether or not your OSPF router will advertise routes it finds from other sources, including its static routes and routes it learns via RIP to the outside world. The External Routing tab won't be enabled unless you check this box. Check it only if you want this particular RRAS router to try to exchange OSPF routing information with its peers. The Areas tab. The Areas tab lists the OSPF areas that your router knows about. You can add, edit, or remove areas from the list using the corresponding buttons below the list box. The Virtual Interfaces tab. The Virtual Interfaces tab is used to create and edit virtual links. Recall that OSPF conceptually divides networks into areas, some of which may be part of the backbone and some of which aren't. Because a non-backbone router won't be connected to the backbone, there has to be some other way to allow backbone and non-backbone routers to share routing information. A virtual link connects a backbone area border router and a non-backbone area border router. Once the link is created, the two routers can share routing information just as though they were connected to the same physical network. The external routing tab. The external routing tab allows you to control which additional routing sources the OSPF components will use. OSPF isn't the only potential source for routing information. Your router can acquire routes from a number of other sources. You might not want all of those routes to be accepted and used though. Figure 9.23, the external routing tab of the OSPF properties dialog box. You can use the two radio buttons at the top: accept routes from all route sources, accept those selected, and ignore routes from all route sources except those selected to control the meaning of the checkboxes in the route sources list. By default, OSPF will accept all routes from all sources. To turn off individual route sources, for instance static routes, check the appropriate box. If you want to reject a route source except for a particular group, use the ignore routes from all route sources except those selected radio button, and then check the route source you do want to use. Okay. Managing static routes. Static routes are simple to manage and configure because they don't participate in any kind of automatic discovery process. Static routes are conceptually very simple. They combine a destination network address with a subnet mask to provide a list of potential destinations. The destination addresses are reached through a particular interface on your router, and they're sent to a specified gateway, normally another router, either on your end or on some remote network. Finally, there's a metric associated with the static route. You create new static routes in two ways: by using the route add command from the command line, or by right-clicking the static routes node in the RRAS console by selecting new static routes. In the following sections, we'll take a look at how these methods work. So I'm going to leave it here this evening for this live stream. If you like listening, please consider like, sharing, and subscribing. Thank you.